Good day, learners. Today we are going to study speed time graph or velocity time graph. So we have our graph here and we have the plot or the graph of the motion of our object. On the left side, on the y-axis here, is our velocity. Take note of the unit. This one is in meter per second. In the abscissa or x-axis, we have the time in seconds. So we have here 2, 4, 6, 8, 10, 12, up to 14 seconds. And our velocity is up to 50 meter per second. So this one is velocity time graph. Now, in speed time graph or velocity time graph, we have three parts. The first part is we are going to analyze the motion of our object in terms of its velocity. The second one is we will compute the acceleration, because the acceleration here now, class, is the slope. In distance time graph, the slope is the velocity, while in speed time graph, the slope represents the acceleration. And then, after the computation, we will get the distance traveled by our object. And what is that one? That is the area under the curve. So to find the distance traveled from 0 to 4, we have area under the curve there. From 4 to 8, we have area of the curve here also. And then from 9 to 14, we have also a curve here under the line. So first, let's do the analysis. We have three regions. We have this region A from 0 to 4 seconds here. And then from 4 seconds to 9 seconds here, we have region B here. And from 9 to 14, we have another region C. Now, let us combine region A and region C because they are the same. Anyway, we are not going to compute for their acceleration yet. We are going to do that one here. So, at region A and region C, what can you say about the motion or the velocity of our object? So here, 2 seconds, here, the velocity is 10. After another 2 seconds at 4, its velocity becomes 20. So what can you say about that one? It means that our velocity is increasing uniformly. So we have a uniform acceleration here. So from 0 to 4, we have a straight line here. It means that we have a uniform acceleration. Means our velocity is increasing uniformly. But our acceleration is not increasing, it is not decreasing, but it is uniform. It does not change. So when we have an acceleration of 5, it will be 5 throughout. But here, the velocity is increasing. You see here, at 1 second here, it's 5 only. Then another second here, at 2 seconds, it becomes 10. Meaning it is increasing by 5 meters per second for every seconds. That's why our velocity keeps on increasing and increasing and increasing. If the velocity is increasing uniformly, we say that we have a uniform acceleration. Means that the acceleration is not changing. It is uniform. Okay, here. So here, at region A, they are the same. Slanting to the right is straight line. Take note, it is a straight line. If it is curved here, our acceleration is not constant or uniform. It is increasing if we have a curve like this. Now, our acceleration is decreasing if our curve is like going here up and then there. It is, our acceleration is not uniform. Region A, we have here uniform acceleration here, or constant acceleration. If we have constant acceleration or uniform acceleration and that is positive, then we say that velocity is increasing. Uniformly. It's increasing uniformly because it's going up. It's positive. Okay. Just like at region C, that from here up to here, we have a uniform acceleration and the velocity is increasing uniformly. Okay. Now, let's have at region B here. What can we say about region B? Region B, 4 seconds, it's 20 meter per second. 5, 20, 6 seconds, we have still 20 meter per second. That's the velocity until on the 9th here, which is still 20 meter per second. So what can we say about the acceleration? Do we have a change in velocity? No, there is no change in velocity. If there's no change in velocity, therefore our acceleration is 0. So there is no acceleration. Acceleration happens only when there is a change in velocity. If the velocity is increasing, there is an acceleration. If the velocity is decreasing, there is also an acceleration. But if there is no change in velocity, then there is no acceleration. So at this point, region B, we don't have acceleration is 0. So we have here acceleration is 0, or we don't have acceleration here. If we don't have acceleration there, then what can we say about the velocity? The velocity is uniform. So here we have a uniform velocity. It means that the velocity does not change. It is not changing. It has uniform velocity. Therefore, in this portion class, we have a uniform motion. So at region B, our object is traveling in uniform motion in which its velocity does not change. So here we can apply our SVT formula. Unlike here, we cannot use that one. We have to modify our formula to suit our velocity time graph. So we have there at region B. Okay, after the analysis here, we have the computation. So what is the acceleration at A, what is the acceleration at B, and what is the acceleration at C? The acceleration now is the slope. So at A, so we are going to find the slope here. How do you find the slope? We draw a triangle, an imaginary triangle here. This one is the height, and this one is the base. Our slope is height over base. So at A, our acceleration, which is actually the slope, is equal to the height. So the height of this triangle is 20 minus 0. So I will not put anymore the 0. So it is 20. That 20 is meter per second. Divided by the time from this 4 to 0. So 4 minus 0 is 4 seconds. So from the unit, we have meter per second or meter per second square. So here we have 20 over 4 is 5, then 5 meter per second, or per second squared. That is our acceleration at region A. At region B, so what can we say about region B? So at region B, our acceleration is equal to 0. So there's no change in velocity. So at region B, you cannot compute. Or when we compute, if we are going to compute, then the height is, there's no triangle there. The height is 0 and the base is 9 minus 4 is 5. 0 over 5 is 0. So acceleration here is 0. So at C, okay, at C we have the slope again. So where's the slope of our triangle? This one is our triangle here. Okay, this one, what is the height? Oh, careful of the height. So here, let's have the 50 there. So 50 minus this one here, there, it's 20. So 50 minus 20, that's the height. What about the time? The time here is 14 minus this one, which is 9. So this one is 9. Okay. So we have 50 minus 20 is 30. This one is meter per second. And 14 minus 9 is 5 seconds here. We divide. At C, our acceleration is equal to 6 meter per second or second squared. That is our acceleration there. Okay, let's have now the third part, which is the distance traveled by our object. So let's have 3 parts here. The first one, the area 1, is the distance traveled by our object from 0 to 4. Let us call that one A sub 1, 0 to 4 seconds. A sub 2, area sub 2, will be the distance traveled by our object from 4 seconds to here, 9 seconds. And the third one, I'm going to put here like a vertical line here, so this one is 9. And the third area, area sub 3, will be this portion here, under the curve, because that is the distance. So we have area under region A is the distance traveled. Area of this one, which is a rectangle, is the distance traveled from 4 to 8. And this one is a trapezium. So you must know the formula for trapezium. So let us find the area of this triangle. So the area of a triangle is equal to 1/2 times base times height. That is area of a triangle, because this one is triangular in shape. So we have 1/2, this one is area 1, 1/2 times the base is 4 minus 0 is 4, times the height of the triangle is 20. So 20 here. So here it's 1/2 times 4 times 20 is 80 divided by 2 is 40 unit of distance meters. So this one is our A sub 1. Okay. So this one is the distance traveled by our object from 0 seconds to 4 seconds. This is a triangle. The next one is area sub 2. So area sub 2 is the distance traveled from 4 seconds to 9 seconds here. 4 to 9 seconds. So let's put an S here. What kind of shape is this? This is a rectangle, rectangular in shape. And the formula for the area of a rectangle is base times height. So this one, the base is this one. What is the base? It's 9 minus 4. So I'll put here, the base is 9 here minus the 4. 9 minus 4 times the height. The height is this one, which is 20 minus 0, or simply I'm going to put 20 because that is minus 0. And then this one is 9 minus 4 is 5 times 20. So our A sub 2 is equal to 100. Unit of distance, meters. So we have A sub 2 is 100 meters. Let's have here A3. So for A3, that's from 9 seconds here to 14 seconds as the distance traveled by our object. This one, you can still divide this into 2. If you don't know the formula for trapezium, you can have the area of this triangle here, just 1/2 this times this, plus the area of the rectangle below. You add them, and the total area will be the distance. But there is an easier way to compute for the area of this curve here under line C, which is a trapezium formula. We add the two parallel sides, get the average, we divide it by 2. So if we have 1, add that one with the opposite side, which is also parallel, and then divide it by 2 times the distance between them. That's the formula for the area of a trapezium. So here we have 4 sides. This side, this, and this. Take note of the parallel sides. Where are the parallel sides here? Usually the parallel sides are opposite. So this one is like this, and this one is like this. So they are not parallel. So we have the parallel sides here, and this are the parallel sides. This and this. So 1 and 2, we are going to add this, and then divide it by 2 times the distance between these two parallel sides, which is this one. Okay, let's have the parallel sides. So this one is 50 minus 0 is 50. Okay, that's 50. Plus this side here. So what is the height of this side here? It's 20 minus 0 is 20. So you have 50 plus 20. 50 plus 20. And don't forget to divide it by 2 because we are getting only the average. Times, how far are they from each other? So that is 14 minus 9. Okay, I'll put here 14 minus 9. 14 minus 9. It's 14 minus 9. That's the distance between them. So here we add 50 and 20 is 70 over 2 times 14 minus 9 is 5. So we have 5 here. And this one is 35. You can divide 35 times 5 is equal to, this one is our A3, therefore this one is 25 carried 2 is 175 meters. So what is the distance traveled by our object? The total. So the total is, we have distance, total distance, we have total is equal to area 1 plus area 2 plus area 3. Then we have, what is area 1? 40 plus area 2 is 100 plus area 3 is 175 So the total distance is equal to, if we add them, we have 315 meters. That is the total distance traveled by our object. What if they ask about the average velocity? Average velocity. So that is equal to the total distance, over the total time. So our average velocity is equal to the total distance, 315 meters, divided by time, which is 14. So we have 14 seconds here. So we have an average velocity of 22.5 meter per second. And that is the end of our topic about speed time graph.